Hi, and welcome to the walkthrough for orbit transfers in Gravity Engine 1.6. We're in the Demos Minigames folder running the orbit transfer scene. Orbit transfers have been a frequently requested feature to have the game engine calculate the maneuvers required to move from one orbit to another orbit. And this scene starts down that path. There are more kinds of orbit transfers that will be added in subsequent releases, but this is the beginning. And part of what's necessary to achieve orbit transfers is the notion of maneuvers and creating a list of course corrections to be executed at future times, because typically an orbit transfer is an initial burn to achieve an ellipse that touches the orbit you want to get to, and then another maneuver at the time where you reach that tangent point to match the path of the target object's orbit. So let's actually see that happen here. So we'll start up the scene, and we'll start by making our objective the high station, and we'll say we want to do an orbit transfer, and there's an option here for a home and orbit transfer. So it calculates the first maneuver we need to do and does it to get us into this transfer orbit, and then it queues up a maneuver that will execute at the point where these orbits touch, and at that time it will apply that maneuver, and now our spaceship is in fact in the orbit of the space station that we were trying to match. There's another way we can transfer from one path to another. It doesn't actually have to be in orbit and doesn't have to be around a single central body, and that's to do manual mode and to actually project forward the trajectories of the object and detect points at which they meet. So if we, for example, want to transfer to the low station, we can pick manual mode. So we now have manual control over our spaceship, so we can add some thrust. That's making our orbit bigger, so what we really want to do is turn our spaceship around here. And each time we turn, it's going to try and recalculate the trajectories. So let's turn ourselves all the way around. See what we're looking at. So our orbit is now starting to get closer and closer, so if we add more thrust here, what happens is our orbit will go inwards, intersect the inner, and we put markers at these places where the trajectories cross each other. If it's a cylinder, that means they cross and the objects are not necessarily at the same point in the orbit, just that the orbits cross. If we get a cube, which is unusual, but we are lucky this time, then it means that they're at the same point in the orbit at the same time. So let's pick that second transfer point. So it's now queued up a maneuver so that when we get to this second intercept point, the objects should be at about the same spot. Maybe it's a bit exaggerated. Our delta for how far apart they are needs a little bit of tuning here. But essentially what's happened is we have manually managed to move from the outer orbit to the inner orbit. There is a deep space station that you can experiment with. The reason it's there is to allow the bielliptic transfer option. So a bielliptic transfer is a kind of transfer that's favorable when the orbit you're transferring to is about 12 times bigger than the orbit you're in. Then it can be, you can save fuel by transferring to an orbit that goes far beyond the deep space station, making a second transfer to an orbit that comes down and touches the deep station, and then a third maneuver that makes your orbit match that orbit. And under certain circumstances that can use less fuel, it will of course take more time. So you can experiment with that. Actually, we could do it here. Deep transfer, we can pick bielliptic. And so you can see that it's going to pick an orbit that goes well outside. And that this is going to take some time. We can press, for example, 4 here to speed this up. And out it will go. The reason I've marked bielliptic as beta is because there is some precision tuning that is still required and that I need to get back to. But at least conceptually it shows you that under some circumstances you can do a different kind of orbit. So now as we get to the peak of this bi-elliptic transfer orbit, it will calculate, well, it will apply this first maneuver here at 482 seconds. We're not quite at 482 seconds. We, of course, move much more slowly at the far part of the ellipse. So now there's a second orbital path that we're going to follow, and we'll follow that all the way up to this tangent point here, where we'll then try and match the circle. Those are the things available in this, what I'm calling mini game. In terms of where the moving parts are, there are scripts attached to this game controller object. As with all game controller objects, it ends up having a fair number of contact points with things in the scene, especially user interface panels and spin rates and so on. So virtually all of the user interaction, including the listing of the intercept points and the listing of the orbit transfer options, all of that code lives in this script. It's not a particularly large script, and it should be fairly easy to work through that script and get grounded into the kinds of things you would want to do with Gravity Engine to support orbit transfers. In addition, there's a time zoom script that controls the time zoom. One other point that is worth noting is that as you zoom in and out, probably notice that the path stayed relatively visually constant. But what's happening there is that the camera script is dynamically adjusting the line width of all of the lines in the scene so that they stay sort of visually about the same size as you zoom in and out. And that's also a useful little script called line scaler that you may find a use for in your own project. Thanks for listening, and I hope this helps get you started on whatever it is you have in mind. Cheers.